Hello and welcome to my channel. So today let's look at Leetcode 986 interval list intersections. You are given two lists of closed intervals, and each list of intervals is pairwise disjoint and in sorted order. Return the intersections of these two interval lists. So the intersection of two closed intervals is a set of real numbers that are either empty or represented as a closed intervals. For example, the intersection of 1, 3 and 2, 4 is 2, 3. So the example 1 is this. It's represented two list of intersections and also the answers. So one thing need to be noticed is if the end of the one intersection is equal to start of the other intersection, it's still considered as I mean, if the end of the one interval is equal to the beginning of the other interval, then it's still considered an intersection. So you output like a 5, 5 in this case. So to represent we are firstly for the two intersection we need two intervals. We need to decide if how it is intersected. So this two is considered intersected, but if you have another one which is this here, then it's not intersected with either one. So to decide if it's intersected, we can check the minimum of and 1 and 2. So if the minimum and 1 and 2 is larger than max of start 1, start 2, so actually if it's larger than or equal to the max start 1, start 2, then it is considered intersected. So for this question, we can use a two-pointer approach to so we can use like I for the first list and J for the second list, and then we alternatively increment I and J in the loop. So the time complexity is will be O over n. N is the length of the total length, the length of first list plus the length of a second list. So and space is we don't use the extra space. So extra space is O1. Unless you count the return array into the space, then yep. So we can say the extra space is O1. So let's start writing the code and maybe explain when doing the implementation. So firstly, we want to define like an intersection a list, so that we can add to this intersection list. And So then we, as I said, we want to have 2 pointers. One is I, the other is j. So we can when the yeah. Also, we want to get the length maybe. N1 is first list length. N2 is second length. So when I is smaller than N1 and j is smaller than N2, so we can check. So as I mentioned, we want to firstly get the end of this both the intersections and get the minimum of that. J. So that's L. Then we can get R of R will be the max of begin. So if L is smaller than or equal to R, means there is an intersection. So we just add add this interval to the L and R. So then we need to check which one we need to increment. So we can increment the list which has a smaller end. So assume that this is the second list and this is the first list. So we have so we actually need to first increment the I on the first list because this end is smaller than the end of the interval in the second list. So here, so that's how we decide to increment. So if yeah, actually we can decide if it's smaller than or equal to second list j. Then we increment I. Otherwise, we increment j. So in the end, we need to define an answer 2D array. Actually, we are using extra space because we are using a list. So it's about maximally like ON space. Yeah, so then we can convert that to an array. Let's see if this will work. So, okay. Yeah, maybe we'll just have answer in the. Oh, yeah, here it should be size. So as a like dimension. Um, let's check. Java convert list of array to 2D to so list dot to array. Okay. Okay, there's something wrong. Let's check it. What's wrong in the code? Five. Well, actually, I think it's something messed up here. So the L should be the larger of beginning, and R should be because R is on the right side. R should be the small of end. Check it again. Okay. So let's submit it. Okay, cool. Yeah. So this question is a good example for the two-pointer algorithm. So which you can have like a linear time complexity. So thank you. So if you have any question, please comment on the video. Thank you for